So we need to go back and revisit concentration. Okay, so that's something that you guys would should have been exposed last semester, right? And you should remember a little bit about concentration, but this is just a quick review. So remember that concentration is a mixture, right? Where you have a solvent. This is a solvent, which is found in large amounts, right? And you have a solute, okay? A solute present, and that's found in small amounts. So a solution is a combination of a solute and a solvent. Okay, so and that makes a mixture. So we have two ways to think about solutions: as a diluted solution, where there's very little solute, and a concentrated solution, where there's a lot of solute. Okay, so just quick review. So we looked last semester at different ways to calculate concentration, but in chemistry, we use a very specific one, which is called molarity. And the way molarity works is it looks at the solute in terms of moles, and then the solution, it looks in terms of liters. So this is the formula that we're going to be using. It is a ratio of moles of the solute to volume of the solution. Okay, so make sure that you remember that. So moles of solute per volume of solution. And sometimes it's abbreviated M equals N over V. This big M represents molarity or concentration. Okay, this little n represents moles and the V represents volume, and it has to be in liters. Okay, so that's a key point. It has to be liters. All right, so based on that, let's look at some examples. So let's read this example together. So I'll do a full example, and then I'll pose a question for you guys to work at your own. So let's see over here. So you have a intravenous solution often administered to patients in the hospital. One saline solution contains 0.9 grams of NaCl, so this is your solute, okay, in exactly 100 mLs of solution. And the question is asking, what is the molarity of the solution? Okay, so it gave you a few things here, so let's look at how to put this together. All right, so here's what the problem gave you. And let me start with the black color, and let me draw. All right, so here's what you know. You know that it was giving you 0.9 grams of NaCl, and this is the volume of the solution. Okay, so this is your knowns, right? And you also know how to calculate the molar mass of NaCl, right? We've done a lot of molar mass. You're just going to periodic table and add them up, but you get this number. So those are all your knowns. What is it that the problem is asking for? Well, the problem is asking for concentration, right? What is the molarity? Concentration, okay? What is the concentration of this solution? This is the formula that you need to use. Okay, so looking at this formula, and I always let the formula guide me on what are my next steps, okay? So liters of solution. Do I have liters of solution? Not quite. It's not giving me liters, it's giving me milliliters. So I need to quickly convert mLs to liters, okay? And I know I'm gonna do my dimensional analysis for conversion. I know that the given is 100 mLs. I also know that there's 1,000 mLs in 1 liter. Okay. So if I solve this, okay, I'll take 100 and divide it by 1,000. Okay, and that's gonna give me 0.100 liters. Okay, so that's how you convert. Perfect. So now going back to the equation, this is what the problem wants you to solve. Liters of solution, yes, I have liters of solution. Moles of solute, do I have that? Not quite, it's giving me grams. I need to convert to moles. Okay, we've done this in the past. That's why we've done this in the past, and I'm waiting to do this now. So let's convert from grams to moles. Okay, and look at lesson 2 if you forgot how to do that. Okay, again, dimension analysis. Okay, I have 0.90 grams. I know the molar mass is 58.5 grams in 1 mole. Okay, I cancel this out. So now it is going to be 0.90 times 1 divided by 58.5, and it's going to give me about 0.015 moles. So now always go back to the equation. I have liters of solution. I put it here as a mark that I have it. Do I have moles of solute? Yes, it's right here. Perfect. So now I can just plug in an equation. So molarity equals 0.05 moles divided by 0.100 liters. Okay, so if I take 0.015 and divide it by 0.1, it gives me 0.15 molar. And that is my final answer. Okay, so that answer would be 0.15 molar. And the key takeaway point here is that always use your formula to guide your next steps, because each problem is going to be slightly different. But you need to come back here and be like, do I have this? Do I have that? That's the best strategy for this. All right, so on Edpuzzle, there will be a problem for you to solve. If you need to rewind and watch this part again, you may, but I'm going to move on. All right, so hopefully you did very well on your previous checking for understanding, and we can move on to a different question. Okay, so let's read it together. A household laundry bleach is diluted aqueous solution of sodium hypochlorite. It's just bleach. Here's the formula for it. How many moles of solute are present in 1.5 liters of 0.75 molar bleach? Okay, let's look at what's known and what's not known. All right. So it gave me volume. The volume is right here, is the liter. It gave me concentration, right? Every time you see this large or this capital M over here, it means concentration. So it gave me concentration, okay? And the problem is asking how many moles. So the problem is asking for moles. So let's look at this formula and see what it is that we need to achieve. All right, so let me use this. Okay, do I have molarity or do I have concentration? Yes, it's right here. Perfect. Do I have moles of solute? No, that's what the problem is asking. Okay, I don't have that. Do I have liters of solution? Yes, I have liters of solution. Is that the right unit? Yes, it is the right unit. So perfect. So then all I need to do is plug it in. So let me plug it in. It would look like this. 0.70 molar equals moles, I don't know the moles, over 1.5 liters. Okay, so then it become an algebra problem. And let's solve it. Multiply both sides by 1.5. Okay, this cancels with this. Then I'll multiply 1.5 by 0.7, which I already done this. Let's see, it gives me moles equal 1.05. Okay, so that's the answer. Okay, so the number of moles is 1.05. So the answer would be 1.05 moles. Okay, and I got that number just by multiplying 0.7 by 1.5. Okay, so this problem was much, again, more straightforward, but again, was just getting you used to reading those problems and figuring out what's your known, what's your unknown, and then how do I let the formula guide my steps. That's pretty much what comes down to. All right, so I believe there's another problem waiting for you. All right, the last topic that I would like to discuss with you is dilutions. So a dilution, in a dilution, is a solution that has more solvent added to it. Okay, in a dilution, the number of moles of the solute does not change. However, the ratio of moles to solvent does change. Therefore, when you dilute a solution, you maintain the number of moles, but you increase the volume of the solution. So let's see what this looks like. So this is the solvent. This is the solute. Okay. So if I mix them up, it becomes a solution. Okay. In a solution, here's the concentration of it. This is in molarities. So you have 0.80 moles per liter or molar. Let me just write it down, the formula here, so you can see what's going on. So this is moles, right? Moles per liter. All right, so note here that if I remove a little bit of the solution, let me remove a little bit of the solution, the concentration does not change because just removing the solution does not change the ratio of moles to volume. However, so 0.680, if I add more solute, I make the solution concentrated. So see here, because I added more of this, so I make the solution quite concentrated. So now let's make the solution diluted. I make the solution diluted by adding more solvent. Okay, so that's how I get to make a concentrated versus a diluted solution. Okay, so diluted, you add more solvent. Concentrated, you add more solute. All right, so let's look at problems that involve that kind of dilution. So here's another formula that you need to know. Okay, it is very straightforward. It is concentration of the stock, meaning that the more concentrated part of the solution. So concentration of solution times volume of the solution equals, in whatever dilution you made, concentration of the new version of the diluted times volume of the diluted. Okay, so again, if that does not make sense, just read it over here. It says right here. All right, so let's solve a problem involving this. So you have a stock solution that has a concentration of 2.0, okay, and is asking how many milliliters must be diluted with water to prepare 100 ml aqueous solution of 0.4 molar of that solution. Okay, so again, let's look at a knowns and unknowns. So here's the formula. You know the concentration of the stock. You want to know the volume of the stock. Okay, you have the concentration, your target concentration, what you want to make. You have the concentration of your target, which is right here, and you have a volume of your target, which is right here. So you just need to plug it in. It might sound a little complicated, but it's not. Actually, this is way easier than what you guys have been working on. Okay, so here's what you're gonna do. You know that I'll just put S for stock times volume stock. Well, sometimes you're gonna see M1 V1 equals M2 V2. Sometimes you're gonna see that. It does not matter. Okay, M of the diluted times volume of the diluted. All right, then it becomes just a question of plugging it in. 2.00 times, I'll just use times, Vs, I don't know what Vs is, right? That's what the problem is asking, equals M diluted 0.4 times volume diluted. And here it's okay to be in mLs because the question is asking for mLs, okay? So just keep that in mind. As long as you keep an eye on the units, you'll be fine. All right, so then I think I solved this problem over here. I did. All right, becomes again just a quick algebra manipulation. This is your x, right? This is what you're trying to solve for. So I need to remove this 2. This 2 is totally in my way. So let's remove it before we go any further. Perfect. So now I have Vs equals 0.400 times 100 divided by 2. Okay. If you put this in a calculator, you're going to end up with, let's see, Vs equals 20 mLs. Okay, so that's how you would do it. Let's see. Let me just try to kind of put this into a picture. So say you have a stock solution right here. Okay, this is your stock solution. Okay, and here you have 2 molar. So this is the concentration of it. Okay, and you're trying it, and I say, hey, can you make a new solution for me? I want a much weaker. I want the new solution that you need to make it for me. I want that solution to be much weaker, so 0.4 molar. And I need to carry out my reaction. I need about 100 mLs of it. Okay, that's what the problem is saying. Okay, so how much of this stock do you need to add to this? Okay, does that make sense? I need about 100 mL, so let me repeat that again. You have a 2 molar solution, so a very strong stock solution, and you need to make a new solution, just a little weaker, actually much weaker, about 0.4, but I need about 100 mLs of it. Okay, so you would take, that's based on my answer, you would take about 20 mLs of it. You would take 20 mLs, you would take 20 mLs of it and stick it in there, and then the rest you'd add water until you reach 100 mLs. Okay, so that's how you do a dilution. Okay, so the answer would be 20 mLs, but I want you to have a visual of how it is that you would go about doing that. Okay, so if you need to rewatch this just to make sure that you have understood, obviously I'm here for questions. All right, I think there's a problem waiting for you now.